Cosmologists now realize that to understand what the future may hold, they first have to unravel what happened at the beginning of the universe, at the start of time itself. In our daily lives, time is constant and dependable. It's almost impossible for us to imagine, but before the creation of the universe, there was no time.
We can trace back cosmic history to a stage when everything was very dense, very compressed, very hot. But the further we go back, conditions were so extreme that we can't really rely on any of our common sense intuitions. We can say that time, in the sense we understand it, didn't really exist before that.
So when did the clock start ticking? 12 billion years ago, there was absolutely nothing. No matter, no space, no time. We may never know how or why it happened, but a seething mass of energy smaller than an atom grew from nothing. You're inside the Big Bang, the birth of our universe, a violent fireball of unimaginable heat. For England's astronomer royal Martin Rees, understanding the Big Bang is the key to the universe.
Something that was literally originally only the size of a single atom or smaller, expanded to be large enough to encompass everything in our present universe.
The atoms created 12 billion years ago are still with us today. Every time you take a sip of water, you're swallowing hydrogen atoms that were created at the very beginning of the universe. Most of the atoms in our bodies were created in the first moments of the Big Bang.
We tend to often dissociate ourselves from the universe. We tend to think of asking questions about it versus us. But of course, that's not really true. We're a part of the universe. And when we ask about the origin and evolution of the universe itself, we're really asking questions about the origin and evolution of ourselves.
Since the Big Bang, the universe has continued to grow and expand. To understand just how big it has grown, we need to take an imaginary spaceship ride from the Earth to the edge of the visible universe. Our nearest neighbor is the Moon, just 250,000 miles away. At the center of our solar system, 93 million miles away, is our Sun. After crossing the center of our solar system, we continue our flight beyond the orbit of the Earth. The next planet out is Mars. Beyond the orbit of Mars is the asteroid belt. A billion miles away is the giant outer planet Saturn, almost 1,000 times the size of Earth. As we leave the solar system, we would pass one of our earliest interplanetary explorers, Voyager 1, launched in 1977 and traveling at a mere 40,000 miles per hour. Proxima Centauri and Alpha Centauri, A and B, our nearest stars, are 25 million miles away. Our solar system sits in the quiet suburbs of a spiral galaxy, the Milky Way. a star city containing over 100 billion stars. Every star we can see in the night sky lies within our own galaxy. This is deep space. Out beyond the Milky Way, 10 million miles from Earth, is the next spiral galaxy, Andromeda. Even traveling at the speed of light, it would take 2 million years to reach here. Andromeda and the Milky Way form part of a small cluster of galaxies called the Local Group. But stretching out way beyond the Local Group are much greater clusters of galaxies. If it were possible to travel fast enough for long enough and reach the edge of the known universe, this is what we would see. Uneven clusters of galaxies, a pattern that was predetermined in the very first second of the Big Bang. This is as far as our spaceship can take us. We are now 50 billion trillion miles from Earth. This is where science ends and speculation begins. Astronomers may never see what lies beyond here. This is where the secrets of the universe are hidden. For centuries, astronomers have been trying to locate our exact position by looking further and further across the vast expanses of deep space.